Mastery exam folder, okay? It's available now. Mastery exam folder. First thing is the list of rules. You should have gotten this a hard copy in recitation, but if you didn't or you lost yours, here it is. Okay, so you got the basic rules, all the trig rules, the inverse trig rules. You need to know all those for the mastery exam. The thing with the inverse trig rules, there's really only 3 to learn because each one is just the opposite. The cosine inverse is just the opposite of sine inverse. Cotangent inverse is the opposite of tan inverse, etc. So there's really only 3 things to memorize there, and just which ones are the opposite of which. Okay, so it looks a little worse than it is. And then the general rules. So that's the first thing in that mastery exam folder. The next thing in that is what's called the bank of problems. So here's what the mastery exam is like. Everyone listening. The first half of it is 25 super short, easy derivatives. Rate of change, to find the rate of change function. I'll give you an example in a second. Super short, super easy. 25 of them, 2 points each. You're going to do all of those. Okay, you're going to do all of those. The second half, the remaining 50 points, is 10 5-point questions, and those 10 problems on your exam will be ones from this list, which I just posted. Okay? So your second half of your exam will be 10 of these. You don't know which 10 you're going to get, and everyone's going to get a different 10. Okay? Everyone's going to get a different 10, and you don't know which one you're going to get. So you have those available to you to work. You got, 48 hours or 60 hours to do that. Okay? So that's this. Bank of problems for the exam. 48 problems, of which you will have 10, and that will be the second half of your exam. Okay? And then here's the 150 practice problems, which you already have. So let's look at these ones that I picked, the top 5 that you requested. Number 4 first. Number 4. Okay? So we're going to look at number 4, and we're going to say, what's the big picture? What's the structure? Is it quotient? No. The structure is power rule, something to a power. That's the overall. So what is our overall, what is dy dx going to look like? It's going to be 2 times something to the first, right? 2 times something to the first. We'll do outside in here. I'll do outside in. Exterior rate of change is going to be, okay, I'm about to do something that's going to earn you a 0 on the problem, and then you're going to tell me why. Okay, ready? Here we go. So I'm going to do outside in. I'm going to do the rate of change with the power rule, 2 times the inside as it is to the first, and then times the rate of change of the interior. And what's the rate of change of the interior? What's the structure of that? Quotient. So now I'm going to have times a quotient, which is going to be low d high minus high d low over low squared. So low d high minus high d low over low squared. Did I get the quotient rule right? So this is power rule. I did the exterior function as the power rule, 2 times, or with respect to the interior function, right? You don't change that, right? 2 to the first, and then times the rate of change of the interior function. That's the chain rule. Okay, but if I was to write this, so that rate of change function is correct, but on the mastery test, this will earn you a 0. This will earn you a 0. Why will this earn you a 0? It's really, really, yes, sir. Okay, so what did I do? Is an accumulation function equal to its rate of change function? Those are 2 different functions. Students do this all the time.
They write equals. Don't do this. This is communicating something that's false and means you have no idea what the difference between an accumulation function and a rate of change function is. Okay, so instead, what do we want to do? So if you do that, no matter how perfect, how hard it was and how perfect it is, 0 on the problem. Okay, so instead we want to do, we've got, choose your notation, right? We've got lots. We've got dy dx. We've got y prime. Those would be probably the two. If this was f of x, we could do f prime. So those two would be maybe the easiest choice here. dy dx or y prime equals the rate of change function. Don't say it's equal to the accumulation function. Questions on number 4? All right, next one is number 54. Oh, it's really the same problem. Okay, so since I did number 4, so it's just a slightly different quotient rule inside. But the structure of your rate of change function is going to be exactly the same. You'll just have a slightly different quotient rule because we have a different interior function. Are we good? Okay, next one, 94. Okay, that's different. Let's do 94. Place some room for me here. Okay, 94. So, overall structure of that. This is a quotient, so we're the quotient rule. And again, on the mastery test, when something is given to you as a quotient, we're requiring you to use the quotient rule. Don't change it into a product and do product rule. You'll have opportunity to show that you know both. You do need to do that. Sometimes quotient rule will be a lot more straightforward and streamlined than turning it into a product and doing product rule. Okay? So we want to know the quotient rule. So we'll do y prime equals low d high. Okay, so now d high, secant squared x. So rate of change of secant squared x. So we've got to think of that as secant x squared. Is the rate of change tangent x? No, it's the other way around, right? The rate of change of tangent is secant squared. The rate of change of secant squared is not tangent. How do we handle the rate of change of secant squared? What's the structure of that? Something squared, right? Something squared. So we're going to do 2 times secant x to the first. Ooh, I'm not going to have room at all here. Okay, so what I'm going to do is, I'm going to give some room here. I'm going to do y prime equals, okay, here we go. So it's going to be low, and then d high, which is going to be, this is something squared, so it's going to be 2 times secant x times, so that's to the first, times the rate of change of the interior function, secant tangent, secant x, tangent x, okay, minus, same thing, 2 times tangent x to the times the rate of change of the interior, which is secant squared. Okay, that whole thing, that was just the rate of change of, that was d high. That whole thing was just d high. Yes, sir?
If it's like the power rule to a second, you put the 2 in front, do you have to write the rule?
No, I'm just doing that to show that I'm using the power rule. You don't have to write, if it's something squared, you can just write 2 times it. You don't have to write to the first power. Yeah. Yeah, this is the derivative of the interior.
Yeah, but then you have the one that's not being derived on the secant squared x minus tangent squared x. Secant squared x.
That was this all there. You want me to do the derivative of this?
No, I have the derivative of that, but the secant squared x is the derivative of the tangent x, which you did the chain of a function for the tangent squared x. So you add
Totally lost. This is right. I think this is right. Okay. Yeah, make sure you get that worked out because I don't know what you're talking about. Sorry. Yeah. Don't simplify anything. Oh, is this 1 or something? Oh. That's not the point of the mastery test, is to find things like that. So the numerator is 1. This is just a dumb problem. That's what they wanted. We're pretend we didn't know. Okay, so she's brought up that this is equal to 1. And yes, if we were doing this in the real world, we needed this rate of change function. You absolutely want to change that to 1 because then we'd be done a long time ago, right? Be 1 over x. But for practice sake, let's just forget that we know that's 1. This is good practice of quotient rule and chain rule, okay? So yeah, but the mastery test does not have any tricks like that. There's no tricks. We want to see if you know how to find rate of change functions and not recognize trig identities, okay? So how do we do so far? So low d high minus, I'm just going to write high because I don't have room, which is just rewrite that times d low. What's d low? 1 all over. And we got it, okay? Questions on this one? 94. Okay, 144 was probably the most popular one. Let's see what that is. 144. Same thing. Cosecant squared minus cotangent squared is? That's also 1, right? So, now how about this? Can I do this? Is that okay? Yeah, that's what y is, right? If you're simplifying the given function, you can write equals all day long. It's when you're taking the rate of change or taking the derivative and finding the rate of change function. That's a new function derived from accumulation. That's where you can't set it equal. So don't say that it's equal. Okay, this is fine. Okay, so and then again, if you were to do it the long way, it would be just like what I just did. Okay, so I'm not going to take the time to do that again. It'd be 2 cosecant x times the rate of change of negative cosecant cotangent minus 2 cotangent times negative cosecant squared would be the d high, part. Okay, and then the last one is, oh, that's it. Or 150. You guys want 150? 150, there we go. That's a good, different one. Questions on 144? It's just like the last one I did. So 150, overall structure, here's a good one. Just something different. Overall structure of this. This is a product. So your rate of change, the structure of the rate of change will be a product. So we're going to have y prime is going to be first, or derivative of the first times the second, so 20x to the fourth times the second as it is, plus the first, or the derivative of the second times the first. I forgot what we said, but it just, the product rule, the order, just as long as you get both of them, the orders don't matter. So derivative of the first times the second plus the derivative of the second. Okay, so what is the structure of that? Tangent with chain rule, right? So derivative is secant squared with respect to interior as it is times rate of change of this. And don't do quotient rule on something like this. You see, that's negative 1 over x. Quotient rule will be a lot of extra writing. If you change this to negative x to the minus 1. So that interior there is negative x to the minus 1. Rate of change is positive x to the minus 2. So that all of that is the rate of change of the second, tangent of negative 1 over x, times the first. So rate of change of the first times the second as it is, plus rate of change of the second, which is chain rule, times the first as it is. If you've got a constant over a function, don't do quotient rule. Don't do quotient rule. It's more than you need to do. So if it's a constant over a function, you can just take that function to the negative 1 power. Questions on this one? Is that a question?
So for the derivative of tan to the -1 over x, you can turn the -1 over x into negative x to the negative first.
Right. That's what I did right there. Yeah.
When you take the negative, oh wait,
You see it? So -1 times -1 is positive. Decrease. Yeah. See it? So yeah, this is chain rule here. This is what we're doing. Other questions? Okay, so let me just give you a quick snapshot of what the first 25 questions might be like, and we can just take 5 minutes to work on that. So if I didn't address your question that you requested on Top Hat, make sure you get your questions answered. Just want to do the most popular ones. So let's go to this page. Okay, so here's an example of the types of questions that are the first 25. Super easy, okay? Super easy, but, and then so the scoring. I never talked about scoring. Here's how the mastery test works. You need to get if you get 90% on the mastery test or better, then you pass. That's a pass. And if you pass on the first attempt, you get 100. So just work really hard in the next 48 hours to make sure that you're going to pass the first time. And then you get 100 on the exam, and you don't have to keep doing it in the coming weeks. Okay? Otherwise, you have to work really hard after the first attempt, and you're going for a lower score. You're going for a 90. Okay? So just dig in like this is your only chance to do it, and you're going to get your 90% or better on this first attempt. So let's just do these fast, okay? Gotta know your rules of exponents. Okay? The mth root of x to the n is the same as what exponent? X to the. So the power is the numerator of the exponent. The root is the denominator of the exponent. Okay? What's 1 over x to the, say, a? X to the? You gotta know these rules. So, another example, what's 1 over the 4th root of x? X to the what? Denominator makes it negative. This power is 1/4. So my experience is that students really get tripped up on these rules of exponents. Okay? So know these rules of exponents. Know how to use them in combination. All right, let's try these 17. Go. So we want to rewrite that first in order to not have to use chain rule. So if we don't rewrite that, we got to use chain rule. So to avoid chain rule, x to the 3/2. Then use power rule. Did you see that? So did you do this? You got to know your laws of exponents and roots to make them into just power rule. So this is, the power is the numerator of the exponent. The root is the denominator of the exponent. So we have the square root. So this is going to be x to the 3/2. And then, go ahead, keep going. Okay? You get? You should have got 3/2 x to the 1/2. 3/2 x to the 1/2 for the rate of change function for number 2. Okay, so these should be all pretty straightforward until we get to number 8. Number 8, where's Madison? Grayson? Madison. How about number 8? Why? Good, okay. So you got to recognize a constant. So it looks like something to a power, but it's just a number. It's just the number e squared. So it's a constant, so the rate of change is 0. Okay, how about the next one, number 9? Where's Yi Ren? Where's Yi Ren? How about number 9? Pi x to the pi minus 1. So it's power rule. When do you do power rule? When x is in the base. That's called a monomial. When x is in the base, that's when you do power rule. So we're gonna do the power rule. Pi x, and then to get the exact new exponent, you have to write it as pi minus 1. Don't write 2.14. That's close. It's not right. Okay? So don't write 2.14. You got to write pi minus 1 to get the exact exponent. Okay, so I think these probably still should be all straightforward. How about e to the 2x? That should be easy. We'll do it. Where's Malachi? Malachi here? How about Dominique Festa? Dominique? No, because it's multiplied, right? Who is Dominique? Oh, right there. Okay. All right, so what do we got? What's the structure of it? The structure of it is exponential, right? Exponential. So what is the rate of change of e to the something? So what's the rate of change of e to the something? What's that? Yeah, right. E to, yeah. Yep, so the rate of change is just e to the something, but that's just not e to the x. You have an interior function there. Which is? 2 e to the 2x, or e to the 2x times 2. Okay. Sopawade. Yeah. How about the next one? 14. Pi to the 1.5. Okay, good. Another, watch out. This is another constant. This is a constant to a constant power. That just gives you a constant. Y prime is 0. Okay, next. Jacob on. Did you rewrite this first? Okay, so we do it on the fly here. What exponent would this be? X to the what? Where's Brandon? Brandon here? Yeah. Negative 2/3, right? Negative because it's in the denominator. The numerator of the power is, the numerator of the exponent is the power. The denominator of the exponent is the root. And so keep going. Derivative is negative 2/3. X to the, right. Okay, so notice what I did. This is equal to that. It's just a new form of what was given, our accumulation function. The rate of change function is a new function with its own notation, y prime or dy dx. Okay, ln of 7. Rate of change is 1/7, right? 0. It's not 1/7. ln of 7 is a number, just like square root of 7. The natural log of 7. Okay, sine of e. 0. Okay. Make sure you know that you're looking at either a function of x or a constant. If it's a constant, the rate of change is 0. Yes, sir?
Number 15, can we use a quotient?
No, not for this part of the test. On this first half of the exam, it will say no product rule, no quotient rule, no chain rule. Now, they had to use the chain rule on 13, so you would have something like that. That requires the chain rule 13. There's no way to get around it. Is that true? Yeah, okay. So, but yeah, the first 25 questions will be like these, and then, so did I put any of the inverse? So none of the inverse trig functions showed up in this practice set, but you'll have to know those for that first 25. Make sure you know the inverse trig functions as well. Okay? All right, so and this first half of the test, it makes it's unfortunate, but the past experiences show that there'll be a handful of you that won't even make it through this. You'll lose your 10, you'll have more than 10 points lost here, and then we get to be done grading. Okay? So this is like rite of passage to be able to do the real mastery test. Okay? You gotta know these. You gotta have the rules memorized, and you gotta know your rules of exponents. Okay. So use up, so your 10% cushion, it should be for the hard ones, not for these. That 10% cushion should be when those harder ones. Okay, but the harder ones, you have them all. If you put the time in the next 48 hours, everyone should pass this, because you have all those questions, and so you can, obviously you can't memorize, but you know exactly what it's going to be like. All right, so just to review, are there any more requests, the ones I didn't do? Quick request to talk about any of the others? So here's the overview. You're going to do, so in the first half, you're going to do all 25 of the short ones. And then you're going to only do the 10 ones that are designated on your exam, okay? So then you're going to get 10 longer ones. Make sure you do the right 10, okay? Make sure you do the right 10, the ones that you're told to do. Whenever a quotient rule comes up, or whenever a quotient comes up, use the quotient rule, okay? So we want you to know that. If you write anything that implies the original function equals the rate of change function, you will get a 0 on the problem. A function and its derivative are two different functions. They're not equal. Okay? Last thing is, we mentioned this last time. We didn't get to see any like this today. But let me just give you an example. Quick. There's a good one. Everyone do that one. Everyone go. Find the rate of change of the cube root of quantity x to the 5th minus e squared times x. Where's Bjorn Hilding? Bjorn here? Vanessa Barak. She dropped, thank you. Megan Allen. Where's Megan? Megan, how'd this go? Okay. Oh, so you're rewriting the original function? So she started by writing this instead of cube root to the 1/3. Okay, and then rate of change? Good. Right? Okay, so e squared is what? Constant times x. What's the rate of change of any constant times x? Constant. Okay, how's it look? Okay, you will lose credit for this, because if you put this in GC, you will not get this is not the right rate of change function, because what? Multiplication comes before subtraction. And what do we intend to do? We intended to multiply by the rate of change of the interior. And in order to do that, need parentheses. And so this is a habit that lots of you, if past experience proves right, lots of you have this habit of leaving off those parentheses. This is a big problem. If you leave off those parentheses, you wrote down a different function than the right rate of change function, because you're going to multiply first and then subtract d squared. We need to multiply by that whole quantity. So watch out for that. So with the partial credit, you're basically allowed, on the second half, you're allowed one mistake on a question to still get some partial credit. If you get more than one mistake, you get a 0. This is a mastery exam. So the fact that we're even giving you that cushion of one mistake is very generous on a mastery exam. So to get full credit, it's got to be perfect. If you make one mistake, you could have -1 or -2 or -3 depending on the mistake. But 2 mistakes is a 0 on the problem. Okay?